Hi everyone, welcome back. Today we're going to be talking about quadratic equations and how to solve them, and then we're going to move on to quadratic functions. And so the first thing we want to do is talk about solving by factoring. This is one of the first techniques you will learn, and it is all based around this property that real numbers have. Is that for any real or complex numbers a and b, the following two statements are equivalent. If you have the product a times b equal to 0, then either a has to be 0, b has to be 0, or both a and b have to be 0. And if you reword it, it basically means that if you factor and the product of factors are equal to 0, then at least one of your factors had to be 0 to begin with. So this applies not only to numbers, but algebraic expressions, because algebraic expressions just represent a number. So let's look at this example here and recall how to do this. So let me change my color. So we have x squared plus 4x plus 3, and so what you want to do first is, if you're not sure how to factor something like this, you look for the factors of 3. And we're going to look for the factors that will add up to 4. So the factors of 3 are 1 and 3, and that's it. And notice that 1 plus 3 does equal 4. So that works. So when that happens, you're going to have that x squared plus 4x plus 3 equals 0. So you're going to have two factors. One of them are going to be x plus 1, x plus 3, and that's going to equal to 0. And now you apply the zero product property. So now we're going to apply this property and say that x plus 1 equals 0, or x plus 3 equals 0, and that will give us, if we solve for x in both cases, we'll have x equals -1, and doing it over here, we'll get that x equals -3. And so when you're learning how to do this, it's always good to check your work, so let's check. So let's start with x equals to -1. So does -1 squared plus 4 times -1 plus 3 equal to 0? Well, we'll get 1 minus 4 plus 3, and that looks to me to equal 0, so that works. And then looking at x equals -3, well, we're going to take -3 and square it, add it to 4 times -3, add another 3, and see if it equals 0. Well, we're going to get 9 minus 12 plus 3, and again that looks to me to equal 0, so that is true. So both answers are a solution. So our solution is x equals -1, comma, -3. So my next example, I'm going to show you basically something that students will often do that is completely wrong. So notice I had the same basic problem as before, but now we're not going to be equal to 0. One thing that students do a lot is they'll do something like this. They'll say x plus 3 times x plus 1 equals 5, and then they're going to split it up like this: x plus 3 equals 5, or x plus 1 equals 5, and get the x equals 2, or x equals 4. So this is not correct. And let's verify this is not correct by checking our solution. So let's check. So let's check x equals 2. So if we take 2 squared plus 4 times 2 plus 3, does that equal 5? Well, that's going to be 4 plus 8 plus 3, and that definitely does not equal 5. In fact, this equals 15. If we check x equals 4, we're going to get 4 squared plus 4 times 4 plus 3, and we're going to see if that equals to 5. And so we're going to get 16 plus 16 plus 3, and that does not equal 5. In fact, this is 35. So notice that the fact that this equaled 0 is an important fact. The whole error was that they did not take the 5 and move it to the other side. So this, do not do this. Please, save yourself some trassle. That is not correct. So let's go on to our last example down here. So these are a little bit harder examples. But the technique is still basically the same thing here. But instead of looking for factors of 5, what you're going to do is now look for factors of 15 that sum to 8. So notice that the 15 is 5 times 3, and that's not a coincidence because you take this number and multiply it by this, and those are the factors you're going to have to find, and then they're going to have to sum up to equal this 8 in the middle. So let's look at factors of 15. And notice you actually, in these problems, I should have thought about this a little more when I designed it, but you do actually have to take sign into account. So we're going to actually have to look at 1 and 15, negative 1 and negative 15. 2 doesn't go into it, but we have 3 and 5, negative 3 and negative 5, and that's it. So this sums to 16, this sums to negative 16, this sums to 8, and this sums to negative 8. So we want these two as our factors. So, or no, not as our factors. So we want these numbers 3 and 5. So what do? We're going to take this 8x and write it as 3x plus 5x. And this will allow us to factor. So let's do that. So we'll have 3x squared plus 8x plus 5 equal to 0. So we're going to split up that 8x squared like this. And I want to match the 3x with the 3x squared and the 5x with the 5. And then we're going to factor by grouping. So to remind you what it does is you're going to take these two terms, factor out the common factor, which is 3x. And what's left behind? Well, in the first term there's an x. You've taken everything out of the second term, so that just leaves behind a 1. And then we're going to factor a common factor out of these two terms. So we'll get a 5 times x plus 1 equals 0. So notice that turns a sum of 4 terms into a sum of 2 terms. And notice that now the sum with 2 terms have a common factor involved, which is the expression x plus 1. So now we can factor out the x plus 1. And what's left behind? Well, we factored this term out, that leaves behind the 3x. We factored out that term, so that leaves behind the 5. And notice how now this gives us a product of two things equal to 0. So we can apply the zero product property and get x plus 1 equals 0, or 3x plus 5 equal to 0. So this gives me x equals negative 1, or let's do this one out a little bit. We'll get 3x equals negative 5, so x is negative 5 thirds. And these are going to be our solutions. You can check them, but I think your skills are competent enough that you can check these on your own, so I will let you do that, and that'll be the end of this video. So